Welcome to our presentation on experience design for persons living with dementia, current methods and experimental experience. I'm Dr. Bruce Wallace. I'll introduce myself last. I'd like to recognize my co-authors, Sabrina Knapp and Laura Alt, both graduate students that have worked on various aspects of this program. Dr. Rafiq Gubran, an engineering researcher and current VP of Research at the Carleton University with a focus on sensors and analytics and applications within aging and well-being. And then Dr. Neil Thomas and Dr. Frank Knuffel, both physicians with the Briere Continuing Care Hospital Group, and both are specialists in dementia and cognition and aging and cognitive issues. Again, I'm Dr. Bruce Wallace. So, who am I? I'm the Executive Director of the AgeWell National Innovation Hub on Sensors, Analytics, and Mobility, Monitoring Mobility and Memory, and then I have a faculty position or an adjunct research position at Carleton University and an affiliated investigator position at the Briere Research Institute. I'm an engineer by background, and again, my focus is sensors and in the subsequent signal processing of the sensors. And the specific area that I'm interested in is how can we use ambient assessments through sensing to translate into support and information coming back to support independence for people that are aging, to allow them to age in place. And one particular question that comes up is how can we work with and support persons that are living with dementia or mild cognitive impairment, the various stages of cognitive decline that may happen as a result of aging and disease. I'd like to recognize the AgeWell National Center of Excellence platform and National Innovation Hub programs and NSERC for their support of this work. So why are we looking at best practices and user experience? If we're starting to build technology, smart home technology, sensor technologies that are measuring aspects of the well-being, and the key is we want to communicate that information back to an individual, one of the key questions we need to ask is how do we communicate it? And in this particular work, I'm very much interested in the challenge of communicating and connecting with people who have got some level of cognitive decline. It could be mild cognitive impairment, sort of an early stage in decline, or a limited amount of decline, or it could be truly dementia at various levels and stages. So this leads to how do you do user experience design? User experience design, on the other hand, is typically built on a model where you involve the end users, the user interface design team will involve the end users in the design process, working through an iterative process of prototyping, getting feedback, revising it, building in more additional prototypes based on that, and revising it until they get to something that they deem to be a final product. So the question we're now asking in this work is, what happens if the end user has cognitive issues, and as a result, can they be involved, or how could they be involved in this design process so that they can provide valid and legitimate feedback to support the design? So some of the methods that have been suggested in the literature for how it could be done is you could have collaboration with the families and the caregivers. So the example there being you could have the caregivers join the person living with dementia in the design process, directly providing feedback and speaking on their behalf and communicating on their behalf. Or some work has been done where people have literally had the family stand in for the person living with dementia, and so the person living with dementia wasn't even involved in the design. It would be a family caretaker or a family or a loved one speaking on their behalf. The challenge with that is they're a proxy for the person living with dementia. They might have a lot of empathy for them, but they aren't speaking, or can't be assumed that they're speaking truly on behalf of what the person living with dementia thinks or feels or sees or understands or whatever. One of the other issues which leads to needs to adapt traditional prototyping methods is one of the issues of cognitive decline is the inability to handle abstraction. And so, previous research has shown that, cutout models of smart screen application designs were difficult for persons living with dementia and MCI to understand. whereas photographs and things that were more realistic were much easier for them to understand. So we need to think about, and this gets directly into the question of how do you prototype and what are the prototypes you build. And then the last one, empathy can be a design strategy. One of the challenges here is that the actual design team doesn't necessarily understand the person living with dementia and the issues that they're facing. So doing things to actually build a better understanding of the challenges that dementia and cognitive decline care. So what I'm going to do is I'm going to spend some time talking through, we have had a lot of experience working with various user interfaces. And I'll talk about some of our past experiences and some of the places we're going, and some of the learnings we've had from working with different user interfaces with various groups. So in this particular group, we did a study using with a mild cognitive impairment group, and specifically the actual question we were looking at was the potential for games like a word search game to be some sort of a measure of cognitive ability and cognitive capability. And the interesting thing was we found in this study when we looked at how well they interacted with the game, it was a Windows computer-based game, so mouse, keyboard type operation. Most of the participants were able to play the game reasonably successfully. It was a mouse point click on the letters till you find the word. You can see in the little cartoon there that the word parrot is almost completely found. So we can show you that they were able to play it. The interesting thing we saw within some of the participants was the abstraction of an understanding that the mouse they were holding in their hand was controlling the cursor on the screen and making that connection between the two things. So we found that when people were trying to move the cursor, they felt they had to look at their hand, and of course when they were looking at the hand, they couldn't see the cursor. So that was definitely an interesting observation, that the disconnect between the mouse physical movement on a tabletop or a desk and a cursor on the screen was difficult for them. In parallel with the word search study, we also did Sudoku. Again, the same group, actually it was an identical group, they actually played both games. And so the delta here we found is that some were able to play the game, but a lot fewer. Part of the issue and the barrier was Sudoku, and the interface and the complexity of the game was a barrier. The other issue we noted was many of them had very limited to no experience with the game, prior to any cognitive decline, let alone post the cognitive decline. And so there was no historical learning of Sudoku and how to play the game that they could work with and use. The other one is the interface was more complex. There was more things they had to do on the keyboard associated with this game. We actually found some success where we literally put tape with new labels on the keyboard, and some people were able to play more successfully because the keys were labeled instead of enter. It had a more game appropriate name on it. Moving forward, we learned from that and sort of decided that if we were going to do anything with gaming, we needed to move away from mouse and keyboard and screen, sort of traditional computing models. So the next place we went would be a touchscreen tablet, much more direct in capability. In this particular study, we actually used the game with a mild to moderate dementia group. And the interesting thing is regardless of the level of severity of dementia, we actually found they were able to play the game. We had people in that study with MMSE scores as low as 13 for their entry score into the study, which is getting towards the edge of moderate to becoming severe dementia. And even that individual was able to play the game. So the tablet was, and the visuals, the image of it there, was close enough to real life, and that learning from when they were young children of playing this type of game at the carnival was right there and available to them, and they got it right away. They were able to play the game. And I'll jump to the last comment. They actually were able to extend and understand. We were interested in getting a little more knowledge out of the game around the concept of inhibition. So instead of just showing the moles, so the game sort of becomes see motion and hit, we introduced bunnies. It was about 4 moles for every bunny. And the idea being that we like bunnies and we don't want to hit them. So the question was, could they get this inhibition concept and understand it of, if you see a mole, hit it, and if you see a bunny, don't. And they were able to learn that concept. And the even more interesting thing is when we looked at the results for individuals, there was a week-to-week improvement. They'd play the game we did this on a weekly session. They'd play the game on a Tuesday. They would make some progress in the game. They would come back and start over again the following week. And it was interesting, their skill level in the game the following week tended to be better than where they started the first week. And so we found over, depending on the individual, between 3 and 5 weeks, they went from a neophyte in the game to achieving whatever their best performance level was, and with week-to-week improvement, and then they sort of stabilized at that level, unless they actually had some cognitive issues and declines and other changes. Very interesting to see them play. This was a study, it was an opportunistic study we looked at, where we had access to a particular piece of equipment, and we were sort of asking the question of, would it be useful? So the group we were working with is a mild to moderate dementia group. Again, they were in a day program. The particular device was actually created and available to us, but it was actually created with a view on a very healthy individual. So basically it's a balanced device. You stand on a platform, and the platform sort of measures and monitors your center of gravity, which it shows you as a dot on the screen. And the typical model that this device is used is varsity athletes would be asked to baseline themselves on this device, and then on a part of the post-concussion return to play protocol, they would be asked to retest on the device, and the question was, how close were they back to the baseline? So it was trying to be an objective measure as part of the post-concussion process. So one of our questions was, we were looking at was, stability is an interesting measure, precursor to somebody who's going unstable might be at risk of fall. So the question was, could this device be used? And that was our fundamental question. Could aging adults with cognitive decline use the device? And the answer was sort of. Okay, it was safe to use. We had no issues with anybody being injured with using the device, but they had some challenges. The concept of the device was, as you stood on the device, you didn't move, and your feet were positioned in a particular position so that your center of gravity was at the center of the dot. So our research assistant or technician would help you get them positioned. And then you weren't allowed to move your feet until the end of the test. And the question was, could you, with your musculature, keep the center of pressure at the center of the target? The challenge was, with cognitive decline and dementia patients, they had to remember not to move their feet, which may not have been positioned in something they thought was comfortable. And so there was a natural tendency for them to want to move them. And then there was also this disconnect, kind of like the mouse and the keyboard and the screen, which is, did they connect that the dot was actually their center of pressure and they could move the dot around by shifting their weight? Again, there was this disconnect. This was a study we're more or less just finishing. This particular study has proved to be really interesting, and it's starting to open questions on a lot of new user interface questions. The concept we're looking at is dementia care partner dyads. So a person living with dementia and, let's say, a spouse that are living independently together. And one of the issues is the person living with dementia could have, one of the symptoms is confusion and disorientation for time or space, and they could wake in the middle of the night naturally because they needed to go to the bathroom, but get confused about when they were, where they were, or when it was, and leading them to potentially walking out the front door in their pajamas. If they're living in a house and they go outside in the middle of winter, our particular research group is based in Ottawa, Canada, and those minus 20 degrees Celsius temperatures that we can see in the winter are deadly. So the question was, could we come up with a model that would work? With part of the question being, can we offload the caregiver who's literally sleeping one eye open and worried that their partner would walk out the door tonight? So this introduced a whole new concept in user interface design, because what we did is we integrated sensing technologies with smart home systems so that when the person got out of bed, it lit the light in the bathroom, so the person would have that visual cue of where to go. If they went somewhere other than the bathroom in the house, that was safe but wasn't appropriate in the middle of the night, like the living room as an example, it would use sound, typically a prompt out of a smart speaker in the caregiver's voice to say, "Hey, honey, it's the middle of the night, it's time to go back to bed." And only if they got to the door would we do something to wake the caregiver. So the interesting thing here is we now have a really interesting model for a user interface. It's lights going on in the house, and it's audible cues coming out of smart speakers. So fairly abstract because they're coming out of, it's kind of the house is now talking. But the interesting thing is people loved the technology and it actually worked. Caregivers were getting more sleep, and it opens the door for a whole new world of user interface questions, which is exactly how can a house talk to and support a person living with dementia as they age. And this is an area we are very interested in growing our research. So some interesting things came out of this and the background research. Some rules of thumb. Large font size is critical. Clear navigation. You want everything on one screen. You don't want big scroll bars. They have to move forward. Hidden affordances, right? So how do you associate elements with action? So this is the example of the mouse causing the cursor to move. That's that's a hidden affordance, and that was causing a lot of difficulty. Limited motor skills. So you don't want complex user interface that require fine dexterity and things like that. Avoid recall. So again, the question, how do we minimize the amount of things they have to remember, have the system sort of self-contained? Avoid the need, add hints. And this was interesting, you have to add hints and support, but you have to do it in a simple way. Our word game had hints in it, and the participants made use of them. Our Sudoku game had hints in it, and the participants didn't understand them. So it's an example. And then, iconography and abstract thinking. The more realistic things are, the more they will understand them. So, where are we heading? We're looking at using these prompts and building forward. And our major going forward work project and focus is how do we continue to grow this new concept of the support of the smart home? And specifically in the user interface case, what is the right models for how a home communicates with its resident in a meaningful way when you start assuming the resident has cognitive decline, dementia, and other issues, and how will that interface work and work best? Audible, visual, there's all kinds of interesting modalities on how you communicate, but it's a complete new abstract user interface that we're now looking at. I'm not sure how questions will work at this conference, but we'll take any of them if you have them. I'd like to thank your time and again acknowledge my funding partners at the AgeWell National Center of Excellence and NSERC. Thank you very much.